All right, this is the notes that say P9, radical equations word problems. So these are word problems. They're actually really easy. You do get a calculator for them. We're gonna go over number 1 through 3 as the notes, and then he said homework was 6 through 8. So I'll go through the first 3, and then you can go check out the answers to the homework on the back. So we have these situations, all right? Matthew is building a fort where the area in tens of feet is modeled by the equation A equals this. So I do a few things. I always circle my equation so I have it and I can look back to it. And then I want to figure out what my 2 variables represent. So I'll go and look where I find A is area. So I know that A is area. And W is the number of pieces of plywood that he uses. So W is the number of pieces of plywood, or I might say wood. Okay, it's the number of pieces that he uses. So basically they're gonna ask me 2 different things, and in one of them they're gonna ask me to plug in something for A, and one of them will ask me to plug in something for W, and I'm gonna solve. So that's really gonna be fairly simple. So first is, what is the area if he uses 20 pieces of plywood? So 20 is W, and A is what I don't know. So I'm gonna rewrite this formula, leaving A as a variable, and then replace W with whatever W is, in this case is 20. That's it. All I'm gonna do is solve that. So now using what we already know, in this case, area equals 3 plus the square root of 16. I don't even need a calculator for this. The square root of 16 is 4, so area is 3 plus 4, A equals 7. He probably wants you to put a label on your answers. So area is always like square feet, square miles, square whatever. So this is tens of feet. So this is, I guess it's like tens of feet squared is the label that we always put on area. Usually it would just be feet squared. This is weird because it's tens of feet squared. So just put tens of feet squared. All right, in part B, it's gonna be the same equation, but now we're gonna be asked, how many pieces of plywood does he need for an area of 40? So now I put 40 in for A, oops, 3 plus, and I leave the W a W. Hopefully you can see that. It's a plus in between them. And now I use this, the skills that we learned last time to go ahead and solve this. I subtract 3 from both sides. Once the square root is isolated, I'm going to square both sides, and this is where a calculator is really helpful. So 37 squared is 1369. So I have 1369 equals W minus 4. Add 4 to both sides. The number of pieces of plywood is 1373 pieces. And that's it. Oops, sorry. I realized I wasn't on here. Okay, not super complicated. All right, next one is, this one was weird. Like, it's a lot to read, and the wording is weird, but once you get it, hopefully it'll make sense. Catherine works for Scoop's Ice Cream Shop. The amount of ice cream they use, they're calling that IC. So IC is the amount of ice cream, and it's in ounces, is modeled by this equation, where X is the number of customers they have. So X is customers, IC is ounces of ice cream. Now we have another ice cream shop. Rose works for Cone's Ice Cream Shop, and their equation is this. So again, IC stands for ounces of ice cream, and X stands for number of customers. Letter A, if both shops have 10 customers, how much ice cream does each shop use? So first we'll go to Scoops. Okay, in Scoops Ice Cream, if we have 10 customers and X was the number of customers, then Scoops has the square root of 6 times 10, or the square root of 60, which is 7.745. Okay, so how much ice cream does that shop use? 7.745 ounces. The other one, which was called Cones, this is their formula. They want to know how much ice cream with 10 customers, so they are the square root of 7 times 10 minus 9, So that's just the square root of 61, right? 70, yeah. 7.8. Or 7.81. I don't know how many decimal places he wants you to go, but whatever. Okay, and then, so that's easy. But then part B was weird. How many customers did they have if they used the same amount of ice cream? So since IC stands for how much ice cream each store uses, we want that number to be the same. So basically we're gonna say, if this IC equals this IC, this amount of ice cream, then these two things are gonna be equal. We're gonna have the square root of 6x equals the square root of 7x minus 9, and that's what we're trying to solve for this. Okay, so to solve this, I'm gonna go square both sides right away. So this becomes 6x, this becomes 7x minus 9. Let's go solve this. So I subtract 6x and add 9, I get x equals 9. So how many customers did they have if they used the same amount of ice cream? 9 customers. Stupid answer, that's dumb. No one has just 9 customers in a day, but whatever. Okay, there's 2, and then here's 3. The profit in thousands of dollars, so P is profit in dollars, at the parking company is modeled by this, where X is the number of lots they operate. Okay, so P is the amount of profit, X is the number of parking lots that they operate. How much money did they make? So I know that's P is gonna be unknown if they have 9 lots. So 9 is gonna be X. So let's put that into this formula. P equals 3 times the square root of 9 plus 4 minus 1. So this is going to be 3 times the square root of 5 minus 1. Go to your calculator. 3 times square root 5 minus 1 should be 5.7. How much money? $5.70. Oh no, it's thousands of dollars. So 5.70 thousands of dollars. You could just leave your answer like that, just so it's simple. And then part B, how many lots should they have for a profit of $8,000? Okay, this is a little tricky. Because P is profit in thousands, I don't use 8,000 for P. I use 8, because that's how many thousands of dollars are in $8,000. So I just use 8 equals 3 root, excuse me, x plus 4 minus 1. Remember from the last lesson, I have to isolate the square root, so I'm going to add 1. I'm going to divide by 3. Now I can square both sides, and I can subtract 4. So x equals 5. They need to operate 5 lots to make the profit of $8,000. Okay, so hopefully that makes sense. If you have questions, of course, let me know. I'll go post this and the other lesson.